Hey guys, it's Mrs. Landman. This is my first Math 8 video, and I'm trying to help you guys understand how to do the worksheet that I posted yesterday. So we had some notes, but sometimes you read the notes and it feels overwhelming, so it's easier to hear a teacher's voice. So we're going to try it. If you look at the worksheet that you had to complete, so this is the worksheet I'm talking about, I'm going to go over the second problem right there, that problem right there. It's very similar to all the other problems. So if you know how to do this one, you'll know how to do the others. So I've drawn it on my little whiteboard that I have. I'm going to show you how to do it. This problem is like doing a Pythagorean theorem problem twice. And you're going to take the information that's in here and use it, part of it once and then part of it another time. So let's first try to find some right triangles. If you look at this shape, it has a bunch of right angles. Every corner is a right angle. And this diagonal goes from the back top corner down to the front bottom corner. If you look at this diagonal and this side right here, and then at the bottom right there, can you see how there's a triangle that's formed here, there, and there? Right now, it doesn't look like a right triangle because I've drawn this with perspective. But if you think about a box, like a shoe box or a cereal box, we're looking at the bottom of the box, the side of the box, and then a diagonal down the box. This is still a right angle. It just doesn't look like it because we're in a 3D picture, but it is a right triangle. So in this one, we can find some missing values. We know that this height here is 6 centimeters because that's what it is over here, and those heights are the same. We don't know this distance here, and we don't know this dashed diagonal. That's our main goal, our main thing to find. So we're going to call that D. My D is very tiny, but that's a D. We can't find D until we know this diagonal here, which we're going to call A, or any other letter we would like to call it. There's nothing special about A. You can pick whatever letter you want. I know that A is a part of this right triangle right here at the bottom of the box. And this side here is 3 centimeters. This side is 10, and then we have A. So we're going to first do a Pythagorean theorem problem with this triangle at the bottom. When we solve that one, we're going to get this A right here. Then we use that number and 6 to find the diagonal. I know that's a lot, but when you do these a bunch, there's two things that could happen. One, you start to see the pattern of it and you'll understand it and you'll be able to do it every time because it's the same problem every time. Some of you will notice that there's a shortcut that you can take, and you can use that shortcut as well. What I'm going to do is set up an equation using the 3, the 10, and the A. I'm going to redraw it over here. This is 3, this is 10, and the hypotenuse is A. I'm going to solve that one first. So I'm going to press pause and do my work. I want you to also press pause and try to solve just this triangle, not the whole big old thing, just this one. And then you'll unpause and you can check your answer. Okay, so I'm going to pause this. Okay, did you have enough time to try it? Here's what I got. I did 3 squared plus 10 squared equals a squared. If you drew actual squares, that's the right thing also. It's just a different choice of how you do it. This is a 3 by 3, which is 9. This is a 10 by 10, which is 100. You add those together, you get 109. And at the end, you take the square root to get what a is all by itself. Leave it like that. If it's perfect, like square root of 25 or something, do the square root. But 109 is not perfect, so I'm going to leave it the square root of 109. Now I'm going to use that information to create my next equation, my next triangle. So this is the triangle that's inside the box right there with that diagonal right there. It's 6 square root of 109 and D. I'm going to run out of minutes here in my video, so if it cuts me off, there'll be a second video to show you the rest. Write your equation using this one with the Pythagorean theorem. Pause and write it. Okay, here's just the equation. I didn't solve it yet, but that's the equation. I'm going to have to explain the rest of it in the next video. This looks scary right here, but it's not. It's going to be just fine. So I'll, in the next video, explain how to solve this equation to finish your answer.